A boundary should be easy to find. If something has a limited size, there should be a place where it runs out. Then the map arrived. The Planck mission produced the most detailed picture of the early universe ever assembled. Scientists examined the data, traced patterns across the sky, and searched for signs that space might eventually end somewhere. Nothing appeared. No wall, no rim, no distant edge waiting to be located. The map stretched across every direction without revealing a single place that behaved like a boundary. That created an immediate problem. Everyday experience teaches the same lesson. A field has an edge. A lake has a shoreline. A room has walls. Finite things stop somewhere. Yet the most detailed cosmic map ever made failed to show any location where space itself seemed to stop. The assumption survived the search. The evidence did not. A strange possibility began taking its place. The universe could be limited in size while offering no identifiable edge at all. And if no edge can be found anywhere, what exactly makes it finite? The missing edge seemed easy to explain. Maybe it was simply farther away than anyone had managed to see. So, observations kept expanding outward. More regions of the sky were examined. More directions were compared. If a boundary existed somewhere, eventually the universe should begin behaving differently near it. It never did. Wherever astronomers looked, the large-scale structure followed the same pattern. The view changed, the location changed, the direction changed. The result did not. No sudden cutoff appeared. No region looked compressed against a wall. No distortion suggested that space was running out. The expected warning signs of a boundary remained absent. That created a new problem. The simplest explanation depended on distance. It assumed the edge existed and had simply not been reached yet. But every additional observation removed another place where that explanation could hide. The search kept moving outward. The evidence stayed exactly where it was. An edge that is merely far away should begin leaving traces long before it is found. Yet the farther observations extended, the more ordinary the universe continued to look. The missing boundary stopped behaving like an undiscovered location. It started behaving like something unnecessary. The challenge was no longer finding where the universe ends. The challenge was understanding why a finite universe might not need an edge at all. A possible answer finally began to emerge. Instead of searching for a missing boundary, some models changed the shape of the problem itself. Imagine moving through space and continuing forward without ever reaching a wall. No barrier appears. No edge blocks the path. The journey simply continues. At first, that sounds like an infinite universe. But in certain closed universe models, it is not. A traveler can keep moving forever without encountering a boundary. Even though the total amount of space remains limited, the motion never ends. The universe does. For the first time, the contradiction starts to weaken. The contradiction began to loosen. The missing edge no longer looked like missing evidence. It started looking like a feature of the universe itself. That possibility changed the search. The goal was no longer to find the location of a hidden edge. It became possible that no edge existed because none was required. The universe might simply be arranged in a way that everyday experience never prepares us to recognize. For a moment, the problem appears close to resolution. A finite universe without a boundary is no longer impossible. But if this explanation is more than an interesting idea, it cannot remain invisible. A shape this large should leave traces behind, and those traces should appear in the data. The idea seemed promising because it offered something the missing edge never could. It provided a way for the universe to be finite without requiring a boundary. The next step was simple: look for the evidence. If this picture was correct, the universe should eventually give itself away. Certain patterns should keep appearing. The same fingerprints should show up again and again. High-precision measurements should reveal at least some sign that the model was real. So the data was examined. Again and again. The Planck mission delivered measurements precise enough to test many of these expectations. Researchers searched for the patterns that finite universe models predicted should be visible. The results refused to cooperate. The expected signatures did not appear clearly enough to serve as confirmation. The solution remained possible, but possibility was no longer the same thing as evidence. That distinction mattered. A model can explain a contradiction and still fail to match what observations actually show. The geometry that seemed capable of resolving the problem now faced a problem of its own. It could not establish itself as the answer. The apparent solution began to weaken. The data did not kill the idea, it simply refused to choose one version of it. The contradiction had not returned in full force, but it had not disappeared either. The search had narrowed, the certainty had not. A difficult possibility started taking shape. The problem might not be the answer. The problem might be access. Some of the information needed to settle the question may simply lie beyond what observations can recover. The assumption seemed reasonable. Better measurements should eventually settle the question. With enough precision, the true shape of space should reveal itself. Then a deeper limitation emerged. Imagine standing inside a vast landscape and mapping everything that can be seen. The measurements become perfect. Every visible detail is recorded. Every available signal is captured. The map keeps improving. The horizon stays exactly where it was. Some possible cosmic geometries may extend so far beyond the observable universe that the visible region contains too little information to distinguish between them. Different realities can produce the same observable picture inside the area available to measure. That changes the meaning of the search. The obstacle is no longer faulty instruments or missing data. Even perfect observations may be confined to a region that does not contain the evidence required to identify the larger structure. The universe might still be finite. It might still have a specific geometry. But the decisive clues could exist beyond the portion of reality that observation can access. The missing edge was never the real obstacle. The obstacle was access. A finite universe might exist. Its shape might be real. The evidence might even surround us. But if the critical clues lie beyond the observable horizon, no improvement in technology changes the situation. The map can become more precise. The visible region does not become larger. The search for the edge ends in a stranger place than anyone expected. Not with a boundary in space, but with a boundary in what observation can reveal.